Now we're in our facility interior. I'm standing next to our 15-foot depth cistern. This tank allows us to do evaluation of systems on the scale model, and that gives us 15 feet of depth, a 4-foot roughly diameter radius. That allows us to put this structure, which is our scale model, in and adjust the buoyancy to take us to various depths up to 15 feet of depth. That's more than plenty of room for us to understand the mechanics of the control loop, as well as the various components that we've put into the system. I want to walk you through our scale model now. The PVC structure is mostly for collision protection as we're lifting it in and out of the tank. It's really only structural. You can see we have a pressure vessel here, which allows us to store the electronics and valve assemblies. Then we have a displacement tank, similar to the large tanks on the Mussel platform, and a compressed air tank here, similar to the smaller pipes that run crosswise on the Mussel platform. These hoses are the same types of hoses, same diameters, same structural consistency as the hoses that we use on the full-scale platform, and that allows us to evaluate flow rates through the valves, flow rates through the hoses, so we understand not just how air is moving, but how much quantity of air we can move in a given time frame. This electronics assembly allows us to test the individual components to make tweaks to our control loop respecting the various capabilities of the electronics. It also allows us to evaluate the control of the various tiers of systems. For us to control the air through the system, we use air-controlled valves, which are in turn controlled by electrically controlled valves. So pneumatic valves that are controlled by electronic valves off the compressed air system. So you have pneumatic valves here and electronic valves here, as well as the electronics that house the control loop, communications to the control system, the user control station, as well as the key sensors, including temperature and pressure measurement at various key points in the system, including the storage tanks and the ambient water depth. Those controls allow us to manage the buoyancy of this system by displacing water with air or allowing water to push air out, changing the overall density of the system, moving it up and down in the water column.